because I know the pattern, right?
Right.
12, 5, 7 divided by 9, 9, 9, 8. Scooch over. 12, 5, 12, 5, 6 divided by 9, 9, 9, 7. Over. 12, 5, 5 divided by 9, 9, 9, 6. And those are all 5. I'm just going to look over it, just kind of say, okay, that looks all right
That's terrible.
before I do it. And then I'm going to hit enter. Oh, actually, well, it tells you right there.
Kind of right there. Yeah.
But I kind of like entering anyways. It just feels better when I hit enter.
It's real.
And so that is the computers in general. So
Yeah.
you kind of just want to do that in general because I've had students kind of just
Oh my
mess
God,
up.
this is-
If you're in there and you start trying to work the second problem, you can't. You have problems because you haven't hit enter yet. It hasn't finished that problem.
I'm sorry, I missed the, how you go back and add the multiplication symbol?
You can. You don't have to. It assumes multiplication
It's like
unless you don't
after
put it.
You put the number, right? And then
Oh yeah. So I didn't even notice that it put multiplication symbols in there
Yeah.
for me. I didn't do that. It assumed multiplication because that's what we do in math.
how did you do that? I'm sorry, I missed the.
I hit enter
just-
at the end and it did it.
No, when you do that, and then you wanna like add.
Oh, you want to scoot over? There's arrow keys right here. So you want to scooch over somewhere? You got little arrow keys to help you. All right.
Where are we rounding this monster
So
off?
play with it, get used to it. Right? It is a really good system, way better than the TI 84 thing that other teachers make you do. It's even better than Excel.
So what would we write the answer?
Yeah. So what is that answer? Ah, my phone went dead. Oh no, okay, it's just dark. So I'm gonna write it here. Really, really small. That 4? 4 zeros and 3. Let me just write it like
Very
that.
cool. So crop it off.
So if I don't tell you where to round, it's a choice, right? The more decimals it gives you, the more safer you are. Kind of thing. I'm a math person, so I like one. Because I'm not telling you where to round. If I told you where to round, no, I probably wouldn't even do that in this class. So, all right. So I'm just worried because, like I said, I might have a test that's my open math stuff, and they do tell you where to round on my open math. Okay, so just be wary of that. All right. So let's do the next problem because the next problem really helps us see something here, and this probability of large numbers thing that's out there in the world. It's not technically in our book, but I just wanted to go over it and make sure we understand what we're doing. So if you have a large enough sample, so think about things, I think I talked about it in general, think about pulling some people from like all of Americans. I want to see how many Democrats I have in something like that. Right? You're talking about all of Americans as your population. And if I'm pulling a small enough sample from all of Americans, right? So we're talking about 5% of America, which is still like 1 million people, kind of thing. I could literally pull 1 million people and still fit this scenario of a small enough sample. So if it's a small enough sample comparatively to our overall population, then we can assume independence, which makes our probability experiment a little bit easier. Right? So thinking of this thing, right? My sample size, so this is the same problem, but we are just using this law now to assume independence. I am sampling a total, so my population is from 10,000 scales, and I am pulling 5 scales. So this is my sample size, right? This is my pot. It's a lot smaller than 5% of the overall population. So my probability really shouldn't change too much from this one. So when in doubt, we use dependency, right, to be safe. But if we have this idea, if we can use this idea, sometimes it makes our numbers easier that we can deal with. So if we have this 5% rule, we do, right? Not that I'm not going to really test you on this 5% rule, but idea to say, oh, well, since I have that rule, I can assume independent stuff. So I can really just say, oh, this is 1259, so if over 10,000, right? Times that again, 5 times. So to the fifth power.
See, I did that up top with my eraser.
And if we use GeoGebra,
It's hella easy.
come on, there we go. Yeah, right?
Yeah.
So 1259 divided by 10,000, and we can raise that. Oh man, I think I messed up. Oh, it did it. Look at
Oh,
that.
sweet.
I didn't put parentheses around it, but it still assumed it. I just scooted over, and I used this little feature, right? You see it? It's like a little power,
Where is
little
it?
superscript things.
Oh, I see.
Under the so it's under the number system.
Okay, and then just hit the 5?
Yeah, so now I'm gonna put 5 there.
Oh, okay, gotcha. Oh, no, it did do it, didn't it?
There's my 5.
Boom.
I didn't write down the whole number, but it's still .0003. There's 4 zeros and a 3. Yeah.
Sorry, Miss, what was the difference? Why did that it's miniature?
So did you scooch over? You have to scoot over to the side of the fraction, and then you can put that binary shape surrounded with parentheses.
It's like damn near the same number.
Yeah, it's so close that does it really matter? That is up to you. I rounded to this place, and so since I rounded to this place, these are exactly the same.
Can I ask a question?
Yeah.
So basically, instead of doing that whole like long process of like subtracting one, blah, 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 like all that, if it's a large population, we can essentially just throw that number and then raise it to the fifth,
Yeah.
always the fifth power?
No. Why are we using the fifth power here?
There's
Oh,
5.
5 scales.
Five scales,
Okay,
yeah.
okay, but the whole
Before we
idea
had
is,
4, right? We had 2
Got
and
you.
stuff like that.
I'm just trying to get an understanding. So earlier, the first going right above
like
it,
that.
we kept on taking away 1. That's because we didn't replace it, and then now we're not taking away.
Right.
We're just going straight. I'm just trying to understand that.
That's the true difference. You're figuring it out there. This is a dependent system, meaning that when I take one out, I'm not putting it back in. So this probability kind of depends on that previous result. This probability depends on that previous result. This probability depends on that previous. So technically it does, but in this case, since it's such a large population, it doesn't really matter. That's what we're saying. All right. So, whereas above, you can see the difference a lot more in that above case. Am I supposed to give you a break or something? So why don't you think about that next one while you're taking a break? You're welcome.
you're welcome. Okay.